Hi, this is Shichen Luke Xu. I'm presenting my submission to the BuildingNet Challenge and my project Multitask 3D Building Understanding with Multimodel Pretraining at Stanford CS231N course. I'm currently a machine learning engineer at Google Geo team and also a SCPD student at Stanford. First, let's talk about my submission to this challenge. I trained a PointNext XL model on BuildingNet-Points check for 3D building part segmentation. The PointNext model improved over PointNet++ model in 3 areas: data augmentation, optimization technique, and the model scaling. On the model architecture, it adds an inverse residual MLP layer, which adds a residual connection to allow the model to train deeper, and it uses separable MLP, which adds MLP layers after the reduction stage. This is similar to MobileNet to reduce the model size. Lastly, the output channel of second MLP layer can be expanded for model scaling. Comparing to the baseline LinkNet, my PointNext XL model applies the same random rotation before voxelization and use the same voxel size, 0.01. I use a smaller sample size, 40,000, and applied all the data computation from PointNext. I loop the dataset 12 times per epoch and only train the model for 100 epoch. For the loss, I use the same weighted cross-entropy loss. The test result of my PointNext XL model marginally beats LinkNet, but significantly improved over PointNet++ by over 100%. In this project, I explored a new task from the BuildingNet dataset, which is called 3D building type classification. It basically produces a class label for the entire building object, such as castle, cathedral, and church. The chart below shows the class distribution of building types, and we can see it's super imbalanced. I propose a multitask model architecture to tackle both building part segmentation task and building type classification task. I explored multiple various learning strategies for this problem, including training from scratch, transfer learning from a different data set, multi-modal pre-training using ULIP framework, and combine that with multitask learning. ULIP is a multimodal learning framework for text, image, and point cloud. For BuildingNet, I generated 64 text prompts, 16 multi-view images and depth map, and pre-processed point cloud model for each 3D building to form the triplet to train with ULIP. I pre-trained PointNext model with ULIP from scratch for 100 epochs, and for comparison, I also loaded the baseline LinkNet model and trained it on ULIP for 50 epochs. The result on the right shows that a good segmentation backbone can also help train a good ULIP classification model. Finally, here is the experiment result on both classification and segmentation tasks. We can see that multitask learning with ULIP pre-training consistently achieves top performance on both tasks. You can find more details in this course poster. And that concludes my presentation. Thank you for listening. If you're interested, the paper will be released on arXiv. Thank you.